Hello dear students, my name is Imi and I'm your mathematics teacher. Niman Hao. Let's start our topic. Our topic is about derivative. How we will find the derivative of a function. Here in this topic we will find the derivative of a function with the help of definition method. So let's start. Finding f dash of x from definition of derivative. Here f dash of x is the derivative of a function. F dash represents the derivative of a function. So given a function f, let's suppose we have a function f here, and f dash of x represents its derivative if it exists. If it exists, if f dash of x, if it exists, can be found by the following four steps. Here are the four steps for this method, and for step 1 we have to find f of x plus partial x. This is the first step. We have to find this term first. Then in next step we have to simplify f of x plus partial x minus f of x. Here it means we have this function f of x, the main function. We have to subtract the main function from this term. This is the second step. In next step we have to divide this term by partial x. Here in step 3, divide f of x plus partial x minus f of x by partial x, here in this way. So we can simplify some terms here in this step, and in the next step we have to apply the limit in this step. In step 4, find or apply the limit partial x tends to 0, f of x plus partial x minus f of x over partial x. After applying the limit, we will find the derivative of a function. So the method of finding derivatives by this process is called differentiation by definition method, or by ab initio method, or from first principle. This method has three names: by definition method, or by ab initio method, or by first principle method. So you must be careful during the exam. If you see the question like this, find the derivative of the following function by definition, like the part A is f of x is equal to x squared. So you have to solve this function to find the derivative of this function by definition method. So you should follow these steps. And if say the next question f of x equals to c, same, you have to solve this question by definition method. So if you have another question, same question but different way, like find the derivative of square root x at x equals to a from the first principle. So you must remember that the first principle is ab initio method or the definition method. So you also solve this question with the same method. So now we will move onwards to solve these questions by this method. Okay. So here we have a question: find the derivative of a function by definition. F of x equals to x squared. This is our function, and we have to find the derivative of this function with the help of definition method. So the first step is f of x plus partial x equals to x plus partial x whole square. This is our first step. In next step we have to subtract f of x plus partial x minus f of x. So this is the value of f of x plus partial x. So x plus partial x whole square minus, here f of x. Where is f of x? F of x is this one. We have to put the value of f of x, which is x square. So we have to simplify a little bit this one. Here, open this formula. It will be x whole square plus partial x whole square plus 2a and b, like 2x partial x minus x square. So x square plus partial x square plus 2x partial x minus x square. So x square and minus x square will be cancelled, and the remaining term will be partial x square plus 2x partial x. So from this term we can take partial x common, and it will be partial x plus 2x, like this one. This is our step 2. In step 3, we have to divide this term. We have to divide this term by partial x. So in step 3, here, f of x plus partial x minus f of x is divided by partial x. So partial x into partial x plus 2x divided by partial x. This is our step 3. So here you can see this partial x will be cancelled with this one, and we have left behind with partial x plus 2x. So in next step, in step 4, we will apply the limit here and we will find the derivative of the function. So apply the limit, applying limit x tends to 0, partial x tends to 0, f of x plus partial x minus f of x divided by partial x equals to limit partial x tends to 0 into partial x plus 2x. So apply the limit here. When you will apply the limit, partial x will be 0 plus 2x, so 2x. So we have the derivative of the function f dash of x this is our required answer. So in this way we will solve these questions with the help of definition method. Got it? Okay, we will. Okay, now we have another problem like find the derivative of square root x at x equals to a from first principles. So this is another question, but we have to follow the first principles method. So in first step we have if f of x equals to under root x. Now we have to apply the first step like f of x plus partial x equals to under root x plus partial x. This is our first step. In next step we have to subtract this term f of x plus partial x minus f of x. We have to subtract the main function from this term. So square root x plus partial x minus square root x. This is our second step. In third step we have to divide this term by partial x. Let's suppose we divide this partial x we divide this term by partial x. Let's see what happens. Let's suppose we divide this term x plus partial x minus x square root x over partial x. In this way, applying this step 3 here, and if we apply the limit here, the step 4, limit x partial x tends to 0, x plus partial x minus square root x over partial x. So if we apply the limit here, you will see that this step will be like this, in this way, x plus 0 minus square root x over 0. So it will be square root x minus square root x over 0. And minus square root x plus square root x will be cancelled also, and it will be like 0 over 0. You can see this. This is undefined form. Here this is undefined form. So we cannot find the derivative if we divide this term by partial x and then we apply the limit. So in order to find the derivative for this kind of function, we have to do what? We have, let's see, we have to rationalize. We have to rationalize this term. How to rationalize? Let's suppose if we have a term 100. If you multiply by 1, we will get 100. So 100 multiplied by 1 by 1. 1 divided by 1, it will be 1. So answer will be 100. Or if you divide 2 by 2, you will get 1. If you divide 8 by 8, you will get 1. So when we multiply any term with 1, we will get the same result. It doesn't affect. So same process for rationalization here. We have to multiply this term with the term square root x plus partial x plus square root x divided by x plus partial x plus square root x. This is the same term. If you can see, we can divide this term and we will get the answer 1. And if we multiply 1 by this term, it doesn't affect. So in this way we can rationalize. So now the numerator will multiply with numerator. So if we multiply, you will see x plus partial x minus square root x into square root x plus partial x plus square root x divided by square root x plus partial x plus square root x. So here you can see this is a formula of a plus b, so a minus b into a plus b. You will see that you can see that this formula a square minus b square equals to a plus b into a minus b. So we can close this formula in this way: square root x plus partial x whole square minus square root x whole square divided by square root x plus partial x plus square root x. So the square will be cancelled with square root and we will left behind with x plus partial x minus x over square root x plus partial x plus square root x. And this x plus x and minus x will be cancelled and we will left behind with partial x over square root x plus partial x plus square root x. This is our step 2. Now we have to divide this term by partial x. Now we can divide this term by partial x, which is our step 3. In step 3 we have to divide this term f of x plus partial x minus f of x divided by partial x. So we can write this term partial x divided by square root x plus partial x plus square root x multiplied by partial x. Now this term is divided by partial x. You can see this partial x will be cancelled with partial x. So what will be left here is 1 over square root x plus partial x plus square root x. Now we have to apply the limit, which is our step 4. So we will apply the limit here. Here, apply the limit, which is our step 4. Limit partial x tends to 0, f of x plus partial x minus f of x over partial x equals to 1 over square root x plus partial x plus square root x. Sorry, I forgot. Here we have to write the limit. Limit partial x tends to 0, 1 over x plus partial x square root plus square root x. So now apply the limit here. When we will apply the limit, you will see x plus 0 square root plus square root x, and it will be 1 over square root x plus square root x, which will be 1 over 2 square root x. And you see here in question, f of x equals to square root x, where x is equals to a. We have to put the value of a here. So f of a equals to 1 over 2 square root a. This is our the required answer. F dash of A. F dash of A is equals to 1 over 2A. Okay, thank you.